Okay, the equation we're starting with today, or excuse me, the worksheet we're starting with today is called Getting Hot in Here. Please do not finish the song. Okay, we're just going to stop right here, Getting Hot in Here. Okay, Susie knows what will be hot inside her car, so before she starts her car, she rolls the windows down to let the car air out. Then after starting the car and turning on her air conditioner, she can feel the temperature in her car gradually start to drop. Okay, an equation to model this change is this equation right here. Okay, where M is the number of minutes since Susie turned on her air conditioner and T is the temperature inside the car in degrees. Okay, so we're going to use a graphing calculator to answer the questions that follow. Okay, and mostly by using a graphing calculator it just means, well, we'll see when we get there. Okay, what was the temperature inside the car at the exact moment she turned on her air conditioner? So when M was 0. But then it says tell two different ways to get the answer. Any ideas? We could substitute the M into the equation. Absolutely. Okay? So I could say T equals 104 minus 8 times the root of 0 plus 1. Right? What is 0 plus 1? 1. What's the square root of 1? 1. What's 8 times 1? So what's 104 minus 8? Anybody have any other idea where we might look for the other answer? Oh, and our calculator! Good! Yay! So, we want to go to a graph? Is that what you said? So a new document? No, we don't want to save the old one. What are we putting in the graph? The equation, okay? 104 minus 8 times the root of x plus 1. So I've clearly broken my calculator. Oh, I have to change the window. Okay. So menu, window settings. Where do I want to start my x value? 0, right? Because 0 is the time, right? Hey, because I know where we're going, can I make this something else? Can I make it like -5? Is that okay? Okay. What about the x max? At least to 106, you said? Any particular reason why 106? Is that your favorite number? Okay. We need to probably count by 10s or 20s, don't we? Okay. What about my y values? So wait, if x is the... What's m represent again? Minutes? Tell me again why we have to go to 106. But isn't that the temperature? I know there's 104 in the problem, but isn't the x value the minutes? We'll go ahead and leave it. It's not going to hurt us. But do you think that may be the best possible thing? Probably not, but we'll leave it. Okay, I want to give you value to your answers. That's okay. Y minimum? Probably 0. Y maximum? This is where what you were talking about comes into play, right? So maybe 110? Oh, you want it to be 106. That's your favorite number. Okay, never mind. And then, how do we want to count? 20s? Graph. Oh my gosh, look. And look, if we were paying attention, it tells us a scale over here. It's okay. It's better that you can figure out your own. I'm good with that. Okay? I hope you are too. But this is what ours looks like, so let's use it. Okay? What are we looking for in the calculator here? M equals 0? So what happens if I go menu and trace? Graph trace? Can I make my x value right here be 0? Whoa. I went too far. Oh my gosh, what was it? 96. Oh my gosh, we got 96. So we can also look at the graph, right? So 96 is what I got. 96 what? Degrees. Okay? What was the temperature inside the car 3 minutes after she turned on her air conditioner? So first we could put it into the equation, like you're saying. So 3 plus 1, what is 3 plus 1? What's the square root of 4? What's 2 times 8? So what's 104 minus 16? 88, are you sure? Okay, we'll see. Because how could we check that? Can I make my x equal 4? Uh-oh. It went from 0 to 5, didn't it? So maybe I don't know how to do this right away. I mean, I do, but obviously you don't, so I don't want to go somewhere you don't know yet. But what if I went to my table? Can I see what it says at 4? I mean at 3? So what I'm looking for is at 3, right? Oh my gosh, look what it says. 88. So another way then, because it asked me again, tell me 2 different ways, is to look where? At the table, right? So 88 degrees. What was the temperature inside Susie's car 1 minute before she turned on her air conditioner? Negative 1 minutes. We cannot have negative time. So you're arguing with me then, yes? So you can have negative time? No. We can't have negative time, but what's true? If we're talking about time before, what kind of notation do we have to use in math class? Negative numbers. Yes. Time before we start something, just like distance. Can we have negative distance? No. But can we talk about distance below or distance behind? And if we do that, what kind of numbers do we have to use? Negative numbers. Does that make sense? Okay, so if I use my equation, t equals 104 minus 8 times the root of negative 1 plus 1. Okay, negative 1 plus 1 is 0, so what's the square root of 0? What's 0 times 8? So what's 104 minus 0? How hot was it 1 minute before she turned on her air conditioner? 104 degrees. What's another way we can know that? We could look at the table, or we could, I don't know why I put took. How about if that we pretend that's an L? Look at the table. Stop making fun of my writing. Susie will not feel comfortable in her car until the temperature reaches 84 degrees. What do you mean we could look at the table? Until I get to 84 where? Oh, in the Y's? Does it ever get exactly to 84? Okay, so that might be a problem, right? Where is it around, though? Around 5. So for now, we'll let it stay for A-R-O-U-N-D, around 5 minutes, right? But is there a way to actually figure out when it is? Where would I plug 84 in? Oh, for T. 84. Okay. So 84 equals 104 minus 8 times the root of m plus 1, right? Now, I know myself, and I know I'm not going to have enough room to write all my work there. Okay, so I'm going to grab a piece of notebook paper real quick. So 84 equals 104 minus 8 times the root of m plus 1. Now, we know from solving square root equations that we have to follow our 4 steps. And we know our first step is to isolate the radical. Okay? Like radical dude, that's exactly right. Okay? So, is this radical isolated? No way. So the first thing I have to do, remember, is subtract 104 from both sides. So 84 minus 104 is what? Negative 20 equals negative 8 times the root of m plus 1. Is the radical isolated? No, it's still being multiplied by negative 8, right? So if I divide both sides by negative 8 divided by negative 8 simplifies to 1. And I have the square root of m plus 1 on this side. And what do I have on the other side? Negative 20 divided by negative 8. So 5 over 2. So 2.5. So is my radical isolated? Yes. We know, we remember from 2 days ago and from yesterday, that after we isolate the radical, then we square both. How about if I spell both right? Sides. Squared, squared. Okay? So what is 2.5 squared? 2.5 squared is 6.25. 6.25 equals, do you remember what I get when I square root, or when I square something that I'm taking the square root of? Okay, remember I told you this the other day, but I'm going to remind you again, just in case. Okay? What happens if I take the square root of 25? What do I get? But what happens if I square that then? What do I get? 25. What happens if I have 121 and I take the square root of it? What's that? 11. But what if I square that? What do I get? 121, right? So can we see something that's common here? If I'm squaring something that I'm taking the square root of, what do I get? Whatever's inside. Does that make sense? Do you remember that? So if I am squaring the square root of m plus 1, what do I end up with? m plus 1. Number 3 says, do you remember? Yeah, if I can spell solve right, what the heck? Solve. Pretend that says solve. Well, I'm just subtracting 1 from both sides, aren't I? M equals 5.25. Well, look what we got. Around 5. We know that M is going to be 5.25. But here's the thing that's different today. Because this says, for what values is this temperature at or below? So this temperature, this value has to be at or below 84. So really the problem that I was working was 84 is, well, it's one of them, right? This value has to be at or below this one. So it's that value is going to be less than or equal to 84. So we're going to use that sign. Let me write it the other way. Hold on just a second. 104 minus 8 times the root of m plus 1. What does that have to do with 84? This value has to be less than or equal to 84. Fair enough? Does that make sense? So when I solve it, I'm going to use exactly the same skills that I just used. And I'm going to get m is less than or equal to 5.25. Does that make sense? Same skills, same steps, all these steps over here. Now we did forget one step. What was it? We forgot to check our work. But if we put 5.25 in here and we add 1, we get 6.25. We take the square root of 6.25, we get 2.5. 8 times 2.5 is 20. 104 minus 20. Oh my gosh, 84. Yay, yay for us. Okay? So I know this is right, so guess what? I also know this is right. Fair enough? Okay, but here's the deal. If the temperature goes below 78 degrees, she says she's too cold. Guys, you don't need to date a girl like Susie because she's too high maintenance for you. Okay? Girls, don't be like Susie. Okay? For what values of m is the temperature 78 degrees or higher? So are we going to do like the exact same equation we just did? 104 minus 8 times the root of m plus 1. Except how does it relate to 78? it has to be what? It has to be greater than or equal to 78, doesn't it? So guess what kind of order I'm going to follow? I'm going to follow the same steps as I did a minute ago, right? Subtract 104 from both sides. Negative 8 times the square root of m plus 1 is greater than or equal to negative... Oh, it's not negative 20 though, is it this time? What is it? If you can't do it in your head, do it in the calculator. Negative 26. Divide both sides by negative 8. It's negative 26 divided by negative 8. And if I want the decimal, I just hit Control Enter. Oh, what the heck did it do? Well, that was weird. Okay, let me try this again. 13 divided by 4, Control Enter. Oh, 3.25. Okay, so I have the square root of m plus 1 is greater than or equal to 3.25. Okay, so I've isolated my radical. Now I have to square both sides. Squared, squared. Here I just get m plus 1, right? Greater than or equal to, what's 3.25 squared? 10.5625. 10.5625. So to solve for m, what do? Subtract 1. So m is going to be greater than or equal to 9.5625. So what does that mean? First of all, let me write this. M is greater than or equal to 9.5625. So when is she going to be comfortable? So the minutes is going to be... Oh my goodness. I totally made a mistake. Did you catch it? It's right here. Right here. What did I do? I divided by a negative number. What do I have to do to this sign if I divide it by a negative number? I have to switch it. So that's a less than, that's a less than, that's a less than. So m is less than 9.5625. Yikes. Guess what? That means on the last problem, we did the same thing. Now, it was an equation, so it wasn't that big of a deal, but when we made it an inequality, guess what? It's a big deal. When we divide or multiply by a negative number, we have to remember to flip that inequality sign. Fair enough? Okay, so when m is less than or equal to 9.5625, she's comfortable. And when m is greater than or equal to 5.25. So how many minutes is that? Approximately 4 minutes, he says. Oh my gosh. She needs to get over herself, doesn't she? Yeah? You good? Okay. Any questions on this? So look at the back. I want you to read through these ways. I know these screenshots are going to not be the ones that you can do on your screen. Okay? But this is the inequality that we talked about a minute ago, isn't it? Okay? With the 84 degrees, you remember that? Okay? Sorry, it says for what values of m is it at or above 84 degrees. So we put the 84 degrees over here. At or above, this value has to be at or above, so greater than or equal to 84. So this is solving it on the graph with a table and algebraically. And really, algebraically is where we have to focus. Okay? So here's 3 examples down here for you. You're ready for example A. Again, we're going to start the same kind of way that we solved radical equations the other day. So number 1, I have to isolate the radical. Is the radical isolated? It is, right? If I cover it up, is anything else on that side of the equation? No. So radical is isolated. So the next step is square both sides. So I get 3x plus 5 is greater than or equal to 16. Okay, so far? If I subtract 5 from both sides, I get 3x is greater than or equal to 11. Then I divide both sides by 3. X is greater than or equal to 11 thirds. Here's what's different in solving inequalities. I got to have a number line. And this isn't my only answer that I'm going to get. Okay? Go back up here to the top right here where the radical is. What has to be true about the number under the radical? It has to be a positive number, doesn't it? Because if we get a negative number underneath the radical, we're going into imaginary numbers, aren't we? We don't want to go there. Whatever is under the radical, in this case 3x plus 5, that has to be what? Greater than or equal to 0. Is it always greater than or equal to 0? Yes. So I solve the regular problem just like normal and get an answer. But then I also have to solve another one. Whatever's under the radical, I have to set it greater than or equal to 0. Okay? I subtract 5 from both sides. I have 3x is greater than or equal to negative 5. And then I divide everything by 3. So x is greater than or equal to negative 5/3. Got it? So on my number line I have negative 5/3, I have 0, and I have 11/3, right? My answer, my solution that I got when I actually solved the inequality says it's everything from here to the right. Okay? This value is my domain. This tells me where my answer is allowed to be. So it's everything to the right of this one, right? Is my answer to the right of my domain? It is, right? So then this is actually all that is my answer. That's all I graph on the number line, because it is where it's allowed to be. My domain says it has to be everything to the right of 5/3, including 5/3. My answer was over here at 11/3 and everything to the right. So that's what I have for my answer. That's all I get. You okay? Okay. So let's look at B. Isolate the radical. So subtract 7 from both sides. The square root of negative 4x plus 15 is greater than 3. Is the radical isolated? Yes. Square both sides. Negative 4x plus 15 is greater than 9. So I want to subtract 15 from both sides and get negative 4x is greater than what? What's 9 minus 15? Negative 6, are you sure? Good. So what do you want to do now? Oh, you just want me to write negative 6? Okay, I can do that. Now divide both sides by negative 4. Uh-oh, 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 uh-oh. Oh, I have to flip the sign. It's got to be less than, what is it, 1.5? Negative 6 divided by negative 4 is 1.5, right? Okay, so I got my number line. What do I have to have on my number line? I have to have a 0 and I have to have a 1.5. What else do I have to have on my number line? I have to take whatever is inside of my radical, in this case negative 4x plus 15, and I have to set it what? Greater than or equal to 0. So subtract 15, negative 4x, greater than or equal to negative 15, divide by negative 4. Uh-oh, uh-oh. X is less than or equal to, what is that? 3.75? So I have to have 0, I have to have 1.5, and I have to have 3.75. So my domain says it has to be everything to the left of 3.75, right? Everything less than or equal to 3.75? Where does my answer say that it lives? Everything left of 1.5. Does my answer lie within my domain? Yes. So I'm done. Does this make sense? Okay. We have time to do one more? Okay. Let's do C. Step number 1. Isolate the radical, right? So I need to subtract 6 from both sides. x minus 1 is less than or equal to the square root of x plus 5. Square both sides? Please be careful. Please be careful. Please be careful. And if I could say it 87 more times, I would say it. What is x minus 1 squared? X squared minus 2x plus 1. Where in the world did she get that? X minus 1 times x minus 1, right? Distribute x squared minus 1x, which is minus 2x, plus 1. You good? It's less than or equal to x plus 5. What kind of problem has this just become? Quadratic, right? So if I subtract x from both sides, because I got to get it to 0, don't I? So I have x squared minus 3x minus 4 is less than or equal to 0. Oh, I'm so glad. I'm so glad about that. Why am I so glad about that? Because I can factor it, and it's all pretty. X minus 4 and x plus 1. So x is going to equal 4 and x is going to equal negative 1, right? Because I set each one of my factors equal to 0. So what have I not been doing a very good job of on these two? My fourth step, right? My fourth step says I have to check my answers, right? Check my answers. And remember, all the way up to here, and even in the checking my answers, that's just solving square root equations, right? If I gave you this problem and that was an equal sign right there, and I said solve, we'd be almost done, except for actually checking our work, right? So like 2 days ago and yesterday, this is where we stopped, isn't it? Well, after we checked our work. It's no different. We've got to check our work. 4 plus 5. 4 plus 5 is 9, right? Okay, so 4 plus 5 is 9. The square root of 9 is 3 plus 6. 9. Does 9 equal 9? Yes, so I know 4 works. That's good. Okay? And guys, when we're checking these, we ignore this sign when we're checking them. They got to be equal. Okay? What about negative 1? Does it work? Negative 1 plus 5 is 4. Negative 1 plus 5 is 4. What's the square root of 4? What's 2 plus 6? 4 equals 8? Oh, no, it doesn't. That's not an answer. When I checked it, it was not an answer. Do you remember what that's called? It's called an extraneous solution. It's an extra answer that just doesn't work. Okay? So maybe I go to my number line too early, because what do we still have to do? Wherever my square root is, what do I have to do with what's under the square root? X plus 5 is greater than or equal to 0. So if I subtract 5 from both sides, I get x is greater than or equal to negative 5. So I need a negative 5, I need a 0, and I need a 4, right? My domain says my answer has to be everything on this side of the 5, doesn't it? Everything greater than 5. But what does my answer say? It has to be less than or equal to 4. My answer says it has to be here, everything that way. But as I'm going that way, what happens here? It stops. Because my domain says it has to stop. It has to stop right here at negative 5. Can't go anywhere past negative 5. My domain says it has to start at 5, negative 5, and go to the right. The answer that I got when I solved the actual inequality was that it has to start at 4 and go left. I can't just go past the edge of my domain. This answer lives only between the negative 5 and the positive 4. Did I just blow your mind? Okay. I don't want brain matter leaking out though, so get a Kleenex. Okay? How are you feeling about this? This page right here, square root inequalities, this is your homework. I do apologize for the wrong title of your homework yesterday. I hope you get over it soon. It was just an accident. Okay? Are we good? Any questions about this? I will be back tomorrow if you have any questions about this. Okay? I do have a meeting at 7:45 Friday morning. Okay? But I will be here after school or even in between classes if you want to come talk then. Okay? All right. I hope you're behaving for the sub, and I hope you're having a nice week. I will see you tomorrow.